Okay, so hello everyone. This video is to explain how to solve exercise 4 question, which is 4.26b. Okay, so in this question, you are asked to you're given x of t is equal to this, and h of t is given here. Okay, so it's a rectangular pulse. Okay. And to verify the convolution property for this pair of signals by showing that the Fourier transform of y of t, which is equal to xt convolved with ht, equals hj omega multiplied by xj omega. So we can look at it as a two-part question, which is first, you need to find what is y of t. Okay, perform the convolution between x of t and h of t. Okay, to answer this convolution question, okay, to solve what is yt using the convolution, it is much easier to do it graphically, okay, whereby you draw what your x of t is and draw what h of t and convolve them together. Okay, so let me show you how it's done, right? So if you look at this, okay, so here what is my x of t, which is given as follows, and this is my h of t. So first we need to draw my xt, which is equal to e this multiplied by this step function, right? So this is what it looks like. Okay, so if you have trouble understanding how to find this, I'm going to show it to you step by step. Okay, first, if I draw x of t equals to e t, okay, this is what I get, right? Okay, as t increases, okay, you have e to the power of something that's getting bigger and bigger, so the magnitude increases. Thus, also, if t becomes larger in the negative value, then it becomes e negative something. So it is equal to 1 over e to the power of some number. So as the magnitude t increases in the negative side, okay, it gets smaller and smaller, right? So this is your exponential function. You can look it up, right? So if I have e minus t minus 2, okay, now I'm shifting this to the right. Okay, this is where it's located. Okay, the point at 0, okay, now is located at the point at this value 2, right? Okay, so if I want to find what is e negative t minus 2, okay, so now I flip. You can see it drawn in the red line here. Okay, I flip it at the vertical axis located at t equals to 2. Okay, why I did not flip at t equals to 0? Well, that's not how you do it. Okay, if this is the equation, you can check, right? If you compare it with the blue line here, okay, whenever the index here is positive, okay, it is located here, right? So when this becomes negative, okay, so now any negative value here, okay, if you plug it inside here, okay, will become negative times another negative, a positive value, right? So it is reflected as the positive value of this index. Okay, so that's why for any value here, you get the same magnitude as what's shown here. So any number that is beyond 2, more than 2, will give a positive value here. Okay, and then it's being multiplied by a negative number. Okay, so that's why it takes the value that is shown by this blue line over here. Okay, so that's why it's flipped. Similarly, okay, anything that is less than 2, okay, will give you a negative, will give you a negative number here, right? And then negative times negative will give you a positive number. So that's why you have this is equal to what is positive for this side. Okay, so spend some time to analyze this, and I hope you understand, right? So finally, okay, this is what I get for e minus t minus 2 multiplied by a step function that is positive 1, okay, for any values greater than 2. Okay, so multiply these two together, you are left with this. Okay, anything less than 2 is taken out, it's not included, right? So now we go to the convolution process of x and t with h of t. Okay, and this is the formula, okay, which is the convolution integral, okay, for a continuous time signal. Okay, so what is x tau? X tau is simply your x of t, okay, with the index of your x-axis to be tau instead of t. Okay, so you have the same shape, right? What about ht minus tau? Okay, so again, what is h of t? So first we draw what is our original h of t, and this is shown here. I'm now using tau instead of t, so this blue line, okay? And if I flip it on the y-axis here, okay, so I get h minus tau, okay, which is shown by this red line, okay? And t minus tau, ht minus tau is just the shifting of this red block here, okay, with t. Okay, so you will notice that here my value is t plus 1, okay, and here it becomes t minus 3, okay, right. So now is the convolution process of, or the multiplication of this with our x of t. Okay, so the result of the multiplication depends on the value of our t. Okay, so we consider several cases. If you look at the first one, okay, if t plus 1 here is less than 2, so if you compare these two, we are multiplying x of tau with ht minus tau. Okay, so whenever our t plus 1 is less than 2, so you will see that the multiplication of these two graphs will equal to 0, right? Okay, so what happens if we start to move this towards the right side? Okay, so as we move, when t plus 1 is bigger than 2, okay, so we can imagine it's going into, okay, it's going to this side, okay, right? Okay, so it's bigger than 2, but t minus 3, which is this value here, it's less than 2. So this red block is located this way, okay? So part of it will intersect with our x of tau, right? And this intersection will give a multiplication result, okay? And this we need to solve it by integrating this multiplied area here, okay? So we are left with e minus tau minus 2, which is our x of tau, because h of tau minus t minus tau is just 1. Okay, so this will give me this, okay, when you include the boundary conditions given here, the limit of the integral. Okay, so be careful, the limit is between t plus 1, which is the higher boundary, and the lower boundary is 2, the lower limit is 2. Okay, so this gives me this value for my y of t. For the final part, okay, is when my ht minus tau is moved to the right all the way, whereby the t plus 1 is located bigger than 2. Just also my the boundary of my rectangular pulse t minus 3 is also beyond 2. Okay. So in this particular condition, okay, if you plot this, the multiplication, okay, and you try to solve this, okay, so the area drawn here, shaded green, is where the multiplication gives results. Anything beyond here as well as here is 0, okay. So this is my limit of my integral from t plus 1 until t minus 3, and this height, okay, because this red is 1, you multiply it with this exponential function here, which is e minus tau minus 2. Okay, so solving this will give me this. Okay, so finally we consolidate our 1, 2, and 3, okay, by including the result of the integration, as well as where it is where the t applies. Okay, so for the first case where t is less than 1, you get 0. For t between 1 to 5, this is my y of t, and for t bigger than 5, this is the result of it. Okay, So I'll stop here and we'll continue in the next video for part 2, where we verify the convolution property by showing that our Fourier transform yj omega is indeed equal to the Fourier transform of h multiplied with the Fourier transform of x.